Let's talk about the process of solving word problems. It's actually a nice standard way to do this, and we'll talk through it on this one, and then as we run into word problems throughout the semester, we can apply this same process. So when we get a word problem, and I'll go through an example in just a bit, first thing you want to do is write down any known quantity based upon the question that you have in front of you. Then you want to write down the quantity that you are solving for. Okay, what is it that you want to know? And then at that point, you start reaching into your biomechanics toolbox and you identify an equation that includes the quantity that you're solving for. And a lot of times I actually claim victory at this stage because once you have the equation, that you need to solve for the problem. A lot of the rest of the steps is just algebra and a bit of math, but identifying the right equation is often the biggest challenge. So right here, we could even at step 3 claim victory at that point. But we'll keep going. So now what you want to do is you want to check the equation to make sure you have only one unknown value. If you have more than one unknown value, you actually either need to find a different equation or you need to use more than one equation. For the purposes of this class, you're almost always going to be finding one equation that has one unknown value. As you get deeper into biomechanics, then you get into situations where you have two unknown parameters, and then you're going to need two equations to work together as opposed to a single equation. But at this stage, we're really going to be focusing on identifying an equation that has the parameter that we're solving for, and it has everything else that we need to know. So we have one unknown, and that's the parameter we want to know about. Once you have that right equation, you're going to manipulate the equation so that the variable that you want to know is all by itself on one side of the equality sign, or usually we put it on the left side. So we're going to do some algebra. Even before we plug any numbers in, rearrange the equation so the one parameter that we want to know is on the one side of the equality sign. And then at that point, we're going to plug in all the parameters, all the values on the other side of the equality sign, and then we're going to do the math. All right, let's go through a problem. So a soccer ball is rolling down the field. At t0, the ball has an initial velocity of 4 meters per second. If the acceleration of the ball is constant at negative 0.3 meters per second squared, how long will it take the ball to come to a complete stop? All right, so let's go through this a little bit in terms of parameters that we know in here and what we don't know. So what we want to find here, well, let's write down what we know. We know initial velocity is equal to 4 meters per second. That is given right here, okay? Initial velocity, 4 meters per second. We also know the final velocity is 0 meters per second. It's a bit implied here because it's going to come to a complete stop. And so that is at the end of the problem, that would be VF is 0 meters per second. What else do we know? Well, we know acceleration is equal to negative 0.3 meters per second squared. All right, that's given right here. And the acceleration is constant. And we also know the initial time that we're dealing with is 0 seconds right here. What do we want to know? We want to know how long it's going to take the ball to be stopped. And so what we're actually solving for here is the final time. And we're going to say we don't know what that is. All right, so now we know some velocity information, we know some acceleration information, we know at least one time parameter, and we don't know this one, but this is what we want to solve for. Now, what do? We reach into our biomechanics toolbox and we identify an equation that has final time in it and all these other parameters as well. All right, in the equation, as you go through your toolbox, you can look at some and you can say, oh, that one doesn't work. if we do displacement equals Fs minus Si, well, that doesn't even have time in it. Well, we could do velocity equals displacement over change in time. Oh, that has the final time in it. It has initial time. I'm going to put a little check mark there. Does not have either of these parameters. And it sort of has a velocity, but we have two velocities. So this equation does not work because they have two unknowns. The equation that hopefully comes to mind is acceleration, and that is change in velocity over change in time is equal to acceleration. All right, now let's go through that equation. I'm going to put that over here. A equals final velocity minus initial velocity divided by the change in time. And I know that right now you're watching this video at the beginning of the semester, and some of these equations you're going to need to learn. And as you go through the semester, you'll be learning more and more equations. You have more and more equations in your toolbox. So this part, it may not be known to you yet, but as you get deeper into the course, you'll be able to identify these equations quickly. All right, so now let's evaluate this equation. We're going to look at step number 4. Well, I know VF, I'm going to put a little check mark right there. I know VF, I know VI, I'm going to put a little check mark right there. I know acceleration, a little check mark right there. And I know initial time, I'll put a check mark there. I don't know final time. I'm going to circle that one. Victory. I have one equation with one unknown parameter. I can solve for that parameter. So really at this point, I'm claiming victory. All right, so this is excellent to be able to get to this point. The next step, however, is we want to do our algebra, and we want to move this parameter over by itself on the one side of the equality sign. So I've got another video on some math review and dealing with fractions. All right, but what we're going to do is ultimately move this one parameter over here. So now how do we do that? Well, the rule that we got to keep in mind is whatever we do to one side of this equality sign, we have to do the same thing to the other side. All right, so just as an example, 4 times 2 equals 8 times 1. So obviously 8 equals 8. I know that's rudimentary, but let's say I decide for whatever reason, I multiply this side by 2. Well, in order for this equality sign to be still valid, I need to do the exact same thing to the other side. So now I get 2 times 8, and I get 16 equals 16. Still true. So whatever we do to one side of the equality sign, we have to do the same exact thing to the other side. So now what do I want to do here? Well, I want to move this all by itself over here. So I'm actually going to multiply this side of the equality sign by the denominator in that fraction. Whatever I do to this side of the equation, I need to do the same exact thing to this side of the equation. So now I get A, I'm just going to rearrange it just for habit of it doesn't matter if the A is on this side or that side, that parentheses equals. Now you should see that this denominator gets canceled out, and I'm only left with the numerator, VF minus VI. All right, well, that's not by itself yet. I got to get rid of the A over here. What do? Well, I'll divide this side of the equality sign by A, and that A will cancel that A out. Well, whatever I do to that side of the equality sign, I need to do the same thing over here. So now these cancel, and I get TF minus TI equals VF minus VI divided by A. I put those in parentheses if we want. Oh, almost there. I've got TF all, I want to get that all by itself. How do I get rid of this part here? Well, if I add TI to this side of the equality sign, that will actually cancel that TI out. So if this is -2 and I add 2, that is 0. So whatever I do to the left side of the equality sign, I need to do the same thing to the other side of the equality sign. And now this will cancel that, and I'm left with TF equals VF minus VI divided by A plus TI. And now I can really claim victory, because now all my parameters that I know are on this side of the equality sign, and the one parameter I don't know is on the left side of the equality. It doesn't matter right or left, but typically we put the unknown to the left side of that equality sign. So now it's just a matter of putting numbers in. And again, this is another level of victory that I was able to do the algebra to get to this stage. All right. And so now we just would do TF equals final velocity, 0 meters per second. And keep your units with the value minus 4 meters per second divided by acceleration, which is negative 0.3 meters per second squared. All right, so now I'm going to get 0 minus 4, so that's negative 4 meters per second divided by negative 0.3 meters per second squared. Negative, negative, negative divided by negative, that's going to cancel that out. And I could do my math a few different ways, but if I just do my math, I'm going to get 13.3 seconds. I've got another video on showing how to do unit analysis so that you can see where that seconds comes from. But maybe you can jump ahead and even try to figure out how do I take this numerator and denominator and end up with seconds instead of these meters per second or meters per second squared. And so that's my final answer. So it would take 13.3 seconds to come to a stop position if we start at 4 meters per second. All right, so not bad. Doing it step by step is important. And again, once you get to where you identify the right equation, so identifying the equation, step 3, that's victory. Make sure it's the right equation. Step 4, that's super victory. Then you're going down the path of being able to do word problems, but do very step by step. Identify what you know, write down what you don't know, write down an equation that has all those parameters in them. Check to make sure there's only one unknown. Manipulate the equation, and then ultimately plug the known values in and do the math. And what's really neat is as you learn these different equations throughout the semester, you can actually practice and rewrite each of these equations so that each individual parameter is by itself on the left-hand side of the equality sign. So when I get to a test to see if you understand how to use this equation, how many questions can I ask? Well, I can actually ask 1, 2, 3, 4, 5 different questions at least here. And I would say solve for TI if you know velocity, final time, final position, and initial position. So jump ahead and just rewrite this equation so TI is all by itself on the left side of the equality sign. Write it again for SI all by itself, SI by SF all by itself, and so forth. Okay, I hope that helps in approaching word problems, that they're not that bad as you go deeper into this course. Okay, thanks everyone.